So then there is another type of penalization that is even less similar to the variable selection problem. That is adding a lambda times summation of aj squared. So that's called the ridge regression. So adding the ridge regression term is never going to make the objective make the aj's to be exactly 0, because the gradient of this term when aj is equal to 0 is actually 0. It doesn't really help zeroing out any particular coefficient, but it does help make the coefficient of the terms that doesn't matter to be quite small. So in practice, the ridge regression in many applications work as well as lasso regression, and particularly if this term is not quadratic, this is much easier to solve, because now you can use what? You can use Newton's method to solve this. It's actually not only differentiable, but has a second order derivative. Well, the lasso optimization problem, there is no way you can solve this using Newton's method, because the first order derivative is not continuous. So second derivatives Hessian doesn't exist, and it doesn't make any sense to use the Hessian. All right. So that's what we usually do for regularization. And this kind of regularization poses a natural problem as to how to choose this lambda. Right? How do we choose lambda? We know the regularization has its value, because if you don't use any lambda, when lambda is very small, particularly in the case when there are a lot more explanatory factors than the number of samples, or in the case of sparse data, your in-sample prediction, say use green, in-sample JIS means in-sample, can be very small, but the out-of-sample OOS can be much larger, which means it's a very good fit in sample, but applied to out of sample is very bad. That means you're overfitting. As you increase your lambda, your in sample, your out of sample is going to improve, right? So you come over here, while your in sample is going to worsen a little bit. And ultimately, if you add too much regularization, all of these are going to increase, right? Because ultimately you're going to make all the coefficients equal to 0, and you're predicting that everything is 0. So everything is going to increase. What's the optimal point of lambda? It's here, right? When the red curve reaches the minimum, that's the optimal amount of regularization I should be using. But remember, we are not allowed to use the out-of-sample data until at the very end of this problem, when we deliver our model. Otherwise, in statistics, it's a practice called snooping. Don't snoop your out-of-sample data until you really fixed your model.